Hey there guys, so we're going to do a video about something very simple, water. So this is properties of water for your video, so you'll just fill in the notes as you go on your handout. Okay, so let's talk about the basic things about water. We'll start with the chemical formula, which hopefully by now you all know that, but it's made up of 2 hydrogen atoms and 1 oxygen atom, alright, giving us the chemical formula of H2O. If we were to look at the molecular picture of what that would look like on simple terms, you can see that there are 2 hydrogen atoms and 1 oxygen atom, which is red. Okay, it is the most important molecule to living things. We can actually go longer without food than we can without water. All right, so it is one of those universal liquids that all living things need. Here is a picture of that molecular structure again. All right, it looks like Mickey Mouse. All right, water is considered to be polar. And what that means is where you see these hydrogen atoms here, those have a positive charge. This oxygen atom has a negative charge. If we look at it at a more electrons and neutrons and protons format, here are those positive hydrogen atoms, here are the negative. So because it's positive on one end and negative on the other, we consider it to be polar. Because water is polar, it dissolves many substances. All right, obviously ones that we know about are sugar, water, salt water, those sort of things dissolve very easily in water. All right, it is considered a universal solvent, meaning it can dissolve any polar substance. All right, here are those examples. Here is an example of salt. When they bond together with the chlorine and the sodium, those water molecules are very attracted to it and therefore can dissolve it. Okay. Solubility review. You actually saw this in 6th grade. Solubility is the measure of how much solute can be dissolved by a solvent. Okay, so a solute could be salt, it could be sugar. The solvent in this case is going to be water. All right, example, sugar dissolving in water. Remember, the hotter the water, the faster it will dissolve. As temperature increases, so does solubility. Remember, solubility is one of those things that is unique to each element on the periodic table or compound. So water has a very unique solubility. Because water is polar, it has 3 distinct properties. One is cohesion. All right, water molecules like to stick together. Surface tension, it's the inward pull of surface water molecules creating a smooth sheet. All right, so for example, if you've ever seen a pond where it's in the morning or a body of water and it's really smooth across the top, that's the action of surface tension. All right, an example, we do have certain animals that can walk across water because of the cohesion and surface tension, or when you do that belly flop into the pool, those water molecules stick together, which is why you hear that loud, obnoxious smack when you hit the water. Because water is polar, it has these properties as well. One is adhesion. All right, water molecules stick to other molecules. All right, so for example, water can stick to the surface of a penny. Water can stick to the windshield of a car. All right, those sort of things. And capillary action, which means water can move up through materials opposite of gravity. If you think about a plant, that's what the roots do. They pull water up through the plant against the force of gravity. Specific heat. All right, the definition is the amount of heat needed to increase the temperature by 1 degree Celsius. All right, water has a very high specific heat. It takes a lot of energy to raise the temperature of water 1 degree Celsius. All right, so specific heat is just the ability to raise the temperature of any substance, in this case water, 1 degree. All right, it's a hot day. The sidewalk is hot. The sandy beach is hot, so you decide to go to the beach. When you jump in the ocean, the water is surprisingly cold. All right, why does that happen? All right, it takes more energy and heat to raise the temperature of the ocean than it does to raise the temperature of the sidewalk or the sand, because the sidewalk and sand have a different specific heat. All right, water specific heat, why is it so high? It's because it's polar. All right, it has that positive and negative charges at each end. They're so attracted to each other that it takes a lot of heat to break those molecules apart. All right, so the hydrogen and oxygen of water are very strongly bonded together. It takes a lot of energy to break them apart, all right, or get them moving quicker, which means if the molecules are moving faster, the state of matter would be changing. Oh, sorry about that. So the second part of your notes, and this should be on a separate sheet, is the distribution of water. Where on our planet do we find our water resources? So we'll go through those. All right. first of all, we know that our planet is made mostly of water. All right, 97% of all the water on the earth is found in an ocean. All right, ocean is salt water, which means that water is unavailable because we can't drink salt water. Only 3% of Earth's water supply is fresh water. All right, and we find fresh water in many places listed there: ice caps and glaciers, groundwater, surface water, and the atmosphere. The sources that we use for our drinking water, like my glass of water that I had at the beginning, all right, we use that from groundwater and surface water. That's where we get our water drinking supply. If we take a look at that 3% of fresh water, 76% of that fresh water is found in ice caps. We can't use it. It's unusable. So 23% is in groundwater, which we use for our drinking and water supply. Only 34 hundredths of a percent is surface water, and only 37 thousandths is found in the atmosphere. So of that 3% of fresh water on Earth, most of it is unusable. We can't use it because it's frozen. We're going to do a little demonstration for you to get an idea of what that's like. Okay, this is totally review for you guys. So we're going to look at the water cycle. All right, the water cycle is that continuous movement of water through the atmosphere. It comes from the oceans, goes to the atmosphere, back to the land, back to the oceans. All right, this constant cycle of water. And your diagram there is already on your notes for you, so there's no need to recreate it. Obviously, what powers the water cycle? The sun. All right, the sun powers most of these processes on our planet. So evaporation is when liquid changes into a gas. In the water cycle, it changes into vapor, which enters the atmosphere. This requires heat from the sun. Okay, so the heating of the day from the sun being present will evaporate water from the oceans, freshwater sources, things like that. Once it reaches the atmosphere and it starts to cool, it condenses through the process of condensation. When it does this, it will actually move into precipitation. Precipitation, you know, is rain, snow, sleet, hail, anything falling from the clouds. All right, when water droplets in the clouds get bigger and heavier, they fall back to the earth. So as these water droplets start to get cool and build, the heavier they get, gravity will take over and pull them back down to the earth. All right, once they reach back to the surface of the earth, a process called runoff. All right, it's precipitation that flows over land into streams and rivers and eventually leading back to the ocean. Okay, in the water cycle, when precipitation reaches the earth, it moves back over the ground. That's called runoff. From this runoff, we get groundwater. All right, so it's precipitation that is transported and collects underground. All right, through a process called infiltration, water that seeps into rocks and between particles of the soil. All right, so if it infiltrates the soil, or percolation, it's the downward movement of water through the soil due to gravity. Okay, so automatically groundwater will seep into the ground and fill in spaces, and then percolation will be where gravity takes over, pulling it through deeper down into the soil. You can build an aquifer from this. It's a body of saturated rock underground through which water can move easily. All right, this rock is said to be permeable, which means it has big spaces in between it, which means water can move pretty freely through it. All right, if you take a look at your diagram here, down at the bottom you see where it says bedrock. All right, that's going to be parent rock, and above that will be the layer of an aquifer, and you can see this river draining will have groundwater, and that will eventually seep into the bedrock, or the layer just above the bedrock. Transpiration, this is when plants actually open up those specialized cells in their leaves, releasing excess water through the process of photosynthesis. This too adds water to the water cycle. And that is your video.